Good day to all. Today our topic is ANOVA Table for experimental data analysis. In previous videos, you may aware about how do we conduct the experiments with the design of experiment concepts, and also I explained with the we can analyze the data with the design expert software. Likewise, we discussed. Today we have to go for manual calculation with the ANOVA analysis. Before going into the topic, you should aware about what are all the assumptions we made before starting ANOVA calculations. In that, the assignable cost and the chance cost available. Based on that assignable cost and the chance cost, only we have get the confident level with the experiment because 4M only not affected our experiment. The other environment conditions also affect our experiment. 4M means men, machine, material, and the methods. Not only these factors affected our experiment, beyond that, mother environment also affect our experiment. So that we should aware about what all the assignable causes available, which means we can change the input parameter. From that, we can get the modified response. But we can't able to change the input parameter with the mother environment and other conditions. So that the causes on responses with the assignable cost and chance cost available, so that every experiment has certain confidence level according to normal distribution curve. There is 95 percentage and 99 percentage confidence level tables available, so that we may consider 95 percentage or 99 percentage of confidence with our conducted experiment. Myself, Dr. B. Suresh Kumar, Department of Mechanical Engineering. Here, the analysis of variance parameters are so sum of squares of total, sum of squares between column, sum of squares between rows, sum of squares between residual error, mean squares between column, mean squares between rows, mean squares between residual error. Let's see what is the meaning for these terms. Before going into the ANOVA table explanation, we should aware about what are all the structure contents are available. It has some rows and column with its table. So that the first column is known as the source of variance. The second, sum of squares. Third, degrees of freedom. Fourth, mean square. The final one, fifth one is variance ratio. What are all the source of variation means between the column, what are all the variations available, between the rows, what are all the variations available, and then what is the residual error available with our experiment. Why we conduct these? Because we may conduct the experiment with the equipment, and also we may measure the responses with the instruments. The equipment and the instruments are having error with its performance. Based on the error, we may get the difference between the experimental value for same consideration of input parameters, so that we may conduct replica experiments of every experimental setup. From that only we may aware our equipment noise and the instrument bias. Okay, equipment always generates noise and instruments always generates bias, because the experimental data difference is always known as noise, and the instrument response measurement has deviation means it should be known as bias. Okay, for example, if you are measure the marble means the light reflection is used to identify the surface quality of the marble surface. In that, the light diffraction is differs from other environment, and also the absorptions of light energy from marbles may be different from every steps, so that the instruments may get errors, and the instruments absorbs the reading with some bad conditions also, so that we may get the improper data collection, so that also our experiment affected. Not only chance cost, I mean assignable cost, the chance cost also affected our experiment, so that we may put some in confidence level on experiments. In that, null hypothesis. For example, I may consider n number of inputs, n number of responses. But how much of my inputs contributing my responses? This is null hypothesis. How can I fix my null hypothesis? Means, for example, according to this problem, I consider three parameters means three engines. Okay, three engines means how I fix my null hypothesis, which means at three engines are the same average, so that I introduce H naught is equal to my mu1 is equal to mu2 is equal to mu3. And then also, I may consider the three engines are not the same average. So I may put like h naught does not is equal to mu one, does not equal to mu two, does not equal to mu three. Likewise, we may fix the null hypothesis value. You may aware about what is the confidence level, what is mean by null hypothesis. Likewise, we may aware. So now we may go for one problem for how do we solve the analysis of variance with the preliminary told techniques. The example problem is an experiment was designed to study the performance of four different detergent, which is detergent A, detergent B, detergent C, and detergent D, for cleaning fuel injectors in engine. Uh, so I consider different fuel injectors at various engines. Here, engine 1, engine 2, engine 3. The following cleaning readings were obtained with the specially designed equipment on 12 tanks. How can I get the 12 tanks? Means here 4 detergent and 3 engines are available. So that 4 plus 3 is equal to 12 tanks of gas distributed over three different models of engine, so that I can identify the cleaning performance with the different detergent on these 12 models. The performance to perform the ANOVA at the zero point zero 0.01 level of significance. What is 0.01? I may have 99% of confidence with my experiment, so that the confidence level is 0.01. Whether there are differences in the detergents or in the engines, I have to identify what difference in the detergents on the engines cleaning performance. This is the objective to solve this problem. How can we solve this problem with the aid of ANOVA? Let's see. The solution, the above data classified according to criteria, which means number one, detergent, number two, engine. And then, in order to signify the calculation code, the data by subtracting 45 from each other. In every table has its own numerical values. From that, I may choose first value 45. From this 45, I can subtract all other elements available with the table. From that, I may give the coding value of the table. Let's see how can I give. This is the problem. Detergent or engine detergent A, B, C, D, engine 1, 2, 3. This is the given problem 45 to 49. And also the total value is also available. Here, how do I convert the table it into coded form? I choose 45 as the first row value. From that, I subtract all the other things. 45 minus 45 is equal to 0. Then 47 minus 45 is equal to 2. And then 48 minus 45 is equal to 3. Likewise, I subtract all the things. And also, I may get the total value 0 minus 2 plus 6 is equal to 4. So that according to the column detergent A, I got the total value is 4. Similar to same, I connect the second row. Here 2, 1, 7 is available. I add the both elements 2 plus 1 plus 7 is equal to 10. And also detergent C and the detergent D. Not only with the Y column, I conduct the same procedure for X column also. Here I consider the first engine 1, 0 plus 2 plus 3 minus 3. Finally, I got 2. And also I subtract, I sum all the elements available with engine 2, and similarly engine 3. I make a summation of x2 is equal to minus 4, summation of x3 is equal to 27. I add the all elements available with the x column is, finally I may get the total as 25. This is the first step of ANOVA calculation. The next, I convert that it into x1 square, x2 square, x3 square, second order polynomial equation, because some regression models also follows the second order polynomial equation. Next video, I will tell about how do we develop the regression models. In this, you should have how do we solve the ANOVA table itself. Okay, so that I reframe the table as like y and x with respect to previous table, and also the total value available with the x and the y. Okay, and then I squared all the things available with the initial table. Okay, here I square is x1 is equal to 0, x2 is equal to minus 2. If I square means I may get 4. After that, x3 is equal to 6, x3 square is equal to 36. I likewise I got other values, and also I made summation of these elements for x1 square, x2 square, x3 square. Likewise, I may get the x1 summation of x1 square 22, x2 square 94, x3 square 201. And then the steps followed. Step 1, n is equal to 12. The observation, how the 12 is came, here you see. According to our problem, there are two 12 values are observed from the experimental setup according to 4 detection 3 engines. So that 4 cross 3 is equal to 12 data I got. So that the capital N is equal to 12 observation. Here, what about the row and the column? According to problem, there is four rows. According to this problem, there is 1 2 3 4 rows and three columns. 1 2 3 columns available. So that rows r is equal to 4, c column is equal to 3, is equal to row into column is equal to 12 number. So that 12 observation is available. And then step 2, total capital T is equal to 25, which means summation of all the x values, which is total, which is 25. Okay, likewise I may get, here you see 18 plus 10 is equal to 28 plus 4 32, 32 minus 7 25. Here also 27 minus 4 plus 2, 27 plus 2 29 minus 4 is equal to 25. So that I can get the total values of x is equal to 25 and total value available with y axis is equal to 25. So that I can get the total T is equal to 25. After that, next step is identify the correction factor. The correction factor formula is equal to T square divided by M. T means the total available with the X and Y column, which means detergent and the engine row and the column. T square divided by N. N means number of observation I made with the experiment. So that T square by N is equal to 25 square is the capital T, 12 is the N. Is equal to 625 divided by 12. After solving, I may get 52.08. And then step 4, total sum of squares. How do I identify the total sum of squares? TSSS is equal to, already I found from the table summation of x1 square, summation of x2 square, summation of x3 square, and also correction factor. So the total sum of squares deals with the addition of x1 square plus summation of x2 square plus summation of x3 square minus correction factor. The correction factor is T square by N. So that I got is equal to 22 plus 94 plus 201. From the previous table, I get these values 22, 94, 201 minus 52.08. From the correction factor, I got 52.08. I solve these with the numerical calculation. I may get 264.92. Likewise, I may get the total sum of squares. And then we calculate every columns sum of square and rows sum of square. How do I calculate the sum of squares of column? Here, what is the value available with the column according to our experiment? The columns are engine 1, engine 2, engine 3. So that the column, sum of squares of column always, also known as sum of columns with respect to engine. Here, SSC is equal to summation of x1 square divided by m1. In previous calculations only we may got the x1 square, sum of x1 square. Already I told how do we got the summation of x1 square from the table divided by n1. How much data are available with the column 1? There is 45, 47, 48, 42. So that 4 values are available with the column. So that I may choose n1 is equal to 4. Similar to same engine 2 also 4. And finally this engine 3 also has its 4. Okay, so that I substitute all the values in the respective formula. I may got 2 square by 4 plus minus 4 square by 4 plus 27 square by 4 minus correction factor is equal to 52.08. So I substitute all the values in the respective equation. I may get the sum of squares of column, which means engines, which is equal to 135.17. After that, I may conduct the same thing for detergent, because rows means rows always deals with the detergent according to this problem. Okay, detergent A first row, detergent B second row, detergent C third row, detergent D fourth row. So that sum of squares of rows, which means detergent. For considering the rows means every row summation of y1 square. What is summation of y1 square? Already I found with the equation summation of y1 is equal to 4. Summation of y2 is equal to 10. Summation of y3 is equal to 18 from the other table. From that I may get the summation of y1, y2, y3 and y4. Here I substitute all the values in it into the available equation, which means 4 square by 4, 10 square by 3 plus 18 square by 3, and also the plus minus 7 square by 3. Why I utilize n1, n2 is equal to 3 means here according to this row there is 3 values 1, 2, 3. So that 3 values are available. So that n1, n2, n3 is equal to 3. Here I missed one value, which means minus 7 square, because fourth row is squares minus 7. So that summation of y4 square is equal to minus 7 square by 3. Minus 52.08 is the correction factor. Finally, I make it 110.91. So that finally, sum of squares of error also we have to identify, because the measuring instrument variations and the equipment always develops the noise. From that also we get the data difference between the every replica experimental data collection. So that we should collect the data about the sum of squares of error. How do I conduct the sum of squares of error means TSS minus sum of squares of columns minus sum of squares of rows. Likewise, 264.92. Previously, I identified what is the value of, how do we identify the 264, which is TSS, total sum of square is equal to 264.92. 264.92 is equal to TSS. SSC is equal to 135.17 and SSR, which is 110.91. Likewise, we identified. Okay, so I substitute all the values in the respective equation, which is sum of squares of error. Likewise, we may identify the errors available with the table. From that, I may get 18.84 as the SSE, sum of squares of error. And then I substitute all the values in ANOVA table, like my source of variance. In first slide, I told about how do we frame the ANOVA table and what is the ANOVA table structure, so that we substitute the value between column, between the engines. Okay, here I may got SSC is equal to 135.17. Here next step is identify the degrees of freedom. Degrees of freedom means C minus 1. C means number of observations with respect to engine. 3 engines are available. So that C is equal to 3, 3 minus 1 is equal to 2. According to the column, I got degrees of freedom is equal to 2. And the mean square column is equal to, always follow, sum of squares column divided by degrees of freedom. Sum of squares of engine column is equal to 135.17 divided by degrees of freedom is equal to 2. So that finally I may got 67.59 is the mean square value. After that, final tabular column is variation of ratio. How do I identify the variation ratio? Which means FC is equal to MSC divided by MSC. MSC I identified through previous column, which is 67.59. I substitute. What is MSC? MSC I identified through residual error column, which means SSC. In previous slide, how do we identify the SSC? I told. Here, there, I got 18.84. I substitute the values here, and also degrees of freedom for error. I consider the column and rows simultaneously, so that C minus 1 into R minus 1. C minus 1 is equal to 2, R minus 1 is equal to 3, because the number of observation available with every row is 4. So that 4 minus 1 is equal to 3. Number of observation available with the column is 3. So that 3 minus 1 is equal to 2. So that 2 into 3 is equal to 6. Okay. From this, I can identify mean square error is equal to sum of square error divided by degrees of freedom. Already we know about degrees of freedom of error is 6. So that sum of square is available with the error is 18.84 divided by 6 is equal to 3.14. I substitute the values 3.14 it into the MSE available with the variation ratio formula, which is FC is equal to MSC divided by MSE is equal to 67.59 divided by 3.14 is equal to 21.52. Likewise, I identified row variations of ratios equal to FR is equal to MSR divided by MSE. MSR I identified through mean square with the rows. Rows means detergent. So that 36.97 divided by 3.14 is equal to FR is equal to 11.17. Okay. These are all the things we have to identify with the ANOVA table. Why I identify FC and FR? Why not FE? Error, we won't identify the variation ratio for error. So that we leave the row. After that, total sum of square. Already I told you how do we evaluate the sum of squares of total in previous slides. And also degrees of freedom for entire element. 6 available with the residual error, 3 with the rows, and 2 with the columns. I sum all the things. 6 plus 3 is equal to 9 plus 2 is equal to 11. So the total degrees of freedom is equal to 11. Likewise, I frame the ANOVA table for identifying the significant and non-significant parameters from the experimental setup. Here, I identify the significant significant parameters from the normal distribution curve. Here, I consider two factors f2, 6 and f3, 6. How do I get these means? 2 is the degrees of freedom of columns. So, 2, 6. 6 means residual error. And also 3 is the between rows and 6. Okay. So that I may get 2 degrees of freedom values 2, 6 and 3, 6. According to this problem, I consider 95% of confidence level because 0.05, the problem statement is given as like 0.05. So that table value, the normal distribution table, I may pick the values for degrees of freedom f of 2, 6, f of 3, 6. For f of 2, 6, I choose the values from normal distribution table is equal to 10.9. And then f of 3, 6 is equal to 9.78. Already the normal distribution table available with the statistics and the numerical book. In that the last page it has statistical tables. From that I may pick the 10.9 and the 9.78 values for the respective f of 2, 6, f of 3, 6. So now I compare the value. If calculated value for FC column according to column here. According to column F2, 6, 2, 6 means according to column 2, 6 I chose. Okay. After that, what is the column variations ratio? There is 21.52, which is calculated value. So that I compare the table value and the calculated value. The calculated value according to the column is 21.52 and 10.9 is the table value. I compare both the things, but our calculated value is greater than table value. Similar to same, I compare the row value. Row also here 11.77 is available. For corresponding table value is 3, 6. I found as like 9.78. I compare the calculated value and the table value for rows also. I can get the calculated value is greater than table value. So that null hypothesis is not accepted for further identification because it does not satisfy my assumptions. According to my assumptions, it does not accepted. There is significant difference among the three engines are available because my assumptions not satisfied with the calculations and the normal distribution table. So that there is significant difference among the engines are available. Likewise, I may get the conclusions from my experiment. If the calculated value is less than 10.9 is available with the column means that parameter has significant on considered responses. And also according to row 9.78 is greater than from calculated value means that parameter also significant has significance on considered responses. Likewise, I made a decision with the aid of mathematics in engineering experiments. So you may aware about how do we calculate the ANOVA table, how do we identify the significant parameters with respect to the experiments you may aware. Thank you.